You think America rose through war and finance. Wrong. What truly stitched this country together and reshaped the global order were 10 mega projects, hard to the bone. Remove even one, and the America we know today wouldn't exist. Number 10. Golden Gate Bridge. Before the Golden Gate Bridge was built, most large modern bridges stood over remote rivers, disconnected from the growth of cities. The Golden Gate Bridge changed that. It marked the moment mega bridge engineering entered a city as core structure and became a working component of urban life. The bridge spans the Golden Gate Strait in San Francisco Bay, linking San Francisco to Marin County in Northern California. This site is brutal. Heavy winds and waves, average wind speeds over 60 kilometers per h-hour, water depths beyond 100 meters, and complex geology. One of the toughest bridge building environments in the world. Construction began in 1933, designed by renowned engineer Joseph Strauss. It used a long span suspension structure with a main span of 1,280 meters. The project took 4 years, cost $35.5 million, and involved over 10,000 workers. On May 27, 1937, the bridge opened to traffic, breaking the transportation barrier between San Francisco and Northern California. It was the longest suspension bridge on Earth, a record it held for nearly 30 years. A trip that once required a 2-hour ferry ride could now be done in 10 minutes. It dramatically boosted transportation efficiency across the Bay Area, drove economic growth in Northern California, and helped shape the formation of a Bay Area city cluster. More than that, with its iconic orange, red color, and monumental form, it became San Francisco's defining landmark, drawing more than 10 million visitors each year and fueling local tourism. Today, the Golden Gate Bridge is not only a transportation link, it's a model of how modern cities and mega engineering can merge into one, defining a city's skyline. Number 9. New Orleans Hurricane Protection System. Unlike other mega projects, this one was built after a city failed. Its meaning isn't just resisting natural disasters. It's about using engineering to inject life back into a broken city. New Orleans sits in the Mississippi River Delta, low-lying terrain where more than 70% of the area is below sea level, making it one of the U.S. cities most vulnerable to hurricanes. In August 2005, Hurricane Katrina struck. The storm surge breached New Orleans' old, aging flood protection system, flooding 80% of the city, killing more than 1,800 people, causing $125 billion in economic losses, and nearly destroying the city. After the disaster, the U.S. government made the decision to rebuild a far stronger hurricane protection system. The project began in 2006, with total investment exceeding $14 billion, making it one of the largest post-disaster reconstruction projects in U.S. history. The new system includes 350 kilometers of levees, 17 large floodgates, multiple storm surge barriers, and pumping stations, using the most advanced engineering technologies and materials available at the time. To increase flood capacity, at the mouth of the Mississippi River, a massive storm surge barrier was built and can be closed before a hurricane arrives to block seawater backflow. The project took 10 years and was fully completed in 2016. This project proves that mega engineering doesn't only create wealth and convenience. It can also deliver redemption after catastrophe, providing critical lessons for coastal cities everywhere. It reduced hurricane-related destruction to the city by 80% and helped New Orleans rise from ruins to once again become an economic and cultural center of the American South. That is enormous progress in the fight between engineering and nature. Number 8. New York City Subway. Some say, without the New York City subway, there is no modern New York. That's not an exaggeration. In the late 19th century, New York's population surged. Manhattan, as the core business district, became extremely dense, and streets were choked with horse-drawn traffic and pedestrians. Urban expansion hit a wall. To solve the transportation crisis and build a modern urban structure, New York launched subway construction in 1900. Then the largest urban underground transit project in the world. The subway faced heavy challenges. Manhattan's underground geology is complex, mixing hard rock with loose sand and silt, making tunnel excavation prone to collapse. Underground, there were also dense networks of water pipes, gas lines, and electrical cables that had to be avoided with precision. They built the first line in just 4 years. On the 27th of October, 1904, the first subway line opened, 9.1 kilometers long with 28 stations. From there, the system expanded continuously, forming a massive network across Manhattan, Brooklyn, Queens, the Bronx, and Staten Island. Today, it totals more than 1,300 kilometers in length, with 472 stations, making it the longest system by route length and the one with the most stations in the world. Today, the subway carries more than 5 million passengers every day. It is the city's transportation backbone, supporting the efficient operation of a global metropolis. Without it, New York could never become a world center of finance, culture, and commerce. Number 7. Trans-Alaska Pipeline System. Alaska holds vast oil resources, with proven reserves exceeding 13 billion barrels. But because it lies near the Arctic Circle, with extreme climate and limited transportation, those resources could be developed for a long time. To move Alaska's oil to the U.S. mainland and achieve energy self-sufficiency, the United States launched construction of the Trans-Alaska Pipeline System in 1974. It was a national-scale energy project built in extreme conditions. The system runs from Prudhoe Bay in northern Alaska to the port of Valdez in southern Alaska, stretching 1,287 kilometers. It crosses permafrost, mountains, rivers, swamps, and other complex terrain. Challenges on a world-class level. First, there is extreme cold. Temperatures can drop to minus 50 degrees Celsius. Second, there is permafrost. Freeze-thaw cycles cause ground settlement. In addition, the region is earthquake-prone, so the pipeline needed strong seismic resistance. The project took 3 years, cost $8 billion, mobilized more than 70,000 workers, and went into operation in 1977. The pipeline fully unlocked Alaska's oil industry, transporting more than 150 million barrels of oil per year to the U.S. mainland. It raised America's oil self-sufficiency rate from 35% in the 1970s to more than 50%. This greatly reduced reliance on Middle Eastern oil. Even today, the system operates reliably in extreme conditions. Its advanced design and construction methods have provided valuable reference for energy projects in other cold regions worldwide. Number 6. Hoover Dam. Before it was built, the Colorado River was a wild, unruly river. Flooding year after year, the surrounding region was barren and desolate, called America's Sahara. The completion of Hoover Dam marked the first time the United States used a mega project to tame the desert, permanently changing the fate of the American Southwest. Construction began in 1931. Located in Black Canyon on the border of Nevada and Arizona, it was then the world's tallest concrete gravity dam, standing 221.4 meters high and 379 meters long, with a total reservoir capacity of 34.85 billion cubic meters. The project took 5 years, cost $49 million, and was completed in 1936. Hoover Dam delivered far beyond expectations. For flood control, it finally restrained Colorado River flooding, protecting downstream cities and farmland. For power generation, the plant's total installed capacity reached 2.08 million kilowatts, supplying abundant electricity to cities like Las Vegas and Phoenix and supporting industrial development. Today, Hoover Dam is not only a key energy and water hub of the Southwest, but also a symbol of American engineering, attracting millions of visitors each year. Number 5. California State Water Project. California is the most populous and economically powerful state in the U.S., but it has a fatal geographic flaw. Its water is distributed in the worst possible way. Northern California is wet and holds about 80% of the state's water supply, while the South is largely desert and semi-desert, yet it concentrates roughly 70% of the population and 90% of the economic activity. To solve this, the United States launched the California State Water Project in 1960. It became one of the largest and most complex cross-regional water transfer systems in American history, and is widely seen as the project that determined whether California could grow into the country's biggest economic engine. The system includes 21 reservoirs, 18 dams, 11 pumping plants, and more than 1,300 kilometers of aqueducts and pipelines. Once implemented, the project completely rewired California's water geography. Each year, it delivers more than 4 billion cubic meters of water to the south, stabilizing agricultural production and supporting both Silicon Valley's tech cluster and the continued expansion of Los Angeles. Today, California's GDP has surpassed $3 trillion, ranking first among us states. And without this water system, none of that would have been possible. You might think plenty of countries build water, transfer projects. Sure, but California's transfer distance exceeds 1,300 kilometers, cutting across mountains and deserts. With 1960s technology, pulling that off was closer to a Mars mission than a normal infrastructure job. Number 4. Interstate highway system. Many people think it as just a road network for convenient driving. In reality, it is the core lifeline of America's unified market, logistics, military mobility, and population movement. After World War II, the U.S. economy entered rapid recovery, but the road system was chaotic, with inconsistent standards across states. State transportation was extremely inefficient, severely limiting the formation of a national market. In 1956, the U.S. Congress passed the Federal Aid Highway Act, formally launching the interstate highway system. The planned total length exceeded 75,000 kilometers, covering major cities and economic regions across 48 states. It was a mega project on an unprecedented scale, requiring massive numbers of bridges, tunnels, grade-separated interchanges, and service areas. To ensure efficiency and safety, the interstate system adopted uniform high standards. Roadway width not less than 24 meters, top speed limits up to 120 kilometers per hour, and a full ban on pedestrians, non-motor vehicles, and low-speed vehicles. After decades of construction, the interstate network took shape and completely changed America's development pattern. Without this highway network, the U.S. could not sustain the world's largest economy or consumer market. Number 3. Transcontinental Railroad. Before it existed, America was only a continental country. In geography, the vast Great Plains, the rugged Rocky Mountains, and scorching deserts completely separated the East and the West. In the mid-19th century, traveling from New York to San Francisco, by land or sea, could take more than half a year and came with unknown dangers. That meant the West's rich minerals and land resources could be developed, and economic growth between East and West was severely imbalanced. To truly stitch together this loosely connected nation, the United States launched the Transcontinental Railroad project in 1863. The difficulty was beyond imagination. Workers often labored more than 16 hours per Dalton Y, and the death rate reached 5%. On May 10, 1869, the two lines met at Promontory Point, Utah, and the 3,073-kilometer Transcontinental Railroad was completed. It cut travel time between coasts from half a year to 7 days, and reduced freight costs by more than 90%. It ignited the development of the American West. Mass migration surged along the rail lines, creating countless new towns and farms. Gold, silver, coal, and other resources flowed continuously to the east, supplying raw materials for the Industrial Revolution, laying a solid foundation for America's rise as an industrial power. Number 2. Panama Canal. This was the first mega project through which the United States used engineering to reshape global trade routes, and its strategic value remains irreplaceable today. Before the canal opened, shipping between America's east and west coasts had to go around Cape Horn at the southern tip of South America. A voyage of 22,000 kilometers. It took months and required ships to cross dangerous waters with frequent storms. To change this, the U.S. took over canal construction in 1904 after a failed French attempt. What it faced were unprecedented challenges. The geological conditions were extremely complex. Much of the route ran through hard rock and soft swamp, making excavation extraordinarily difficult. And engineers also had to solve navigation across the height difference between the two oceans. American engineers innovatively designed a three-step lock system. By raising and lowering water levels inside lock chambers, ships could pass smoothly over the Continental Divide at 26 meters above sea level, an unprecedented breakthrough in the history of hydraulic engineering. On the 15th of August, 1914, the Panama Canal officially opened, shortening the distance between America's two coasts by 14,800 kilometers and cutting travel time from 3 months to less than 1. In both world wars, the canal became the critical passage for the U.S. to move fleets between two oceans, directly strengthening its strategic military deterrence. In peacetime, it became a major hub of global trade, with more than 15,000 ships passing through each year, carrying 5% of global trade and permanently changing the world as shipping system. Without it, the U.S. could not have rapidly moved its two ocean fleets in World War II, and the early shape of global dominance wouldn't even have been possible. Number 1. NASA Apollo program. When people mention it, most think only of Armstrong's line, "One small step for man, one giant leap for mankind." But few realize this wasn't just humanity's first systematic departure from Earth. It was the key engineering project that established America's technological dominance. The Apollo program began in 1961, when the U.S. was at a disadvantage in the space race. To fulfill President Kennedy's promise of landing a man on the moon within a decade, the United States mobilized more than 300,000 researchers, over 20,000 companies, and 120 universities. It took 11 years and cost $25.5 billion, equivalent to more than $230 billion today. During the program, countless world-class challenges were solved, from spacesuits that could withstand extreme lunar temperature swings, to guidance systems that could precisely control a soft landing, to tracking and measurement networks enabling complex Earth-to-Moon communications. Every breakthrough reset humanity's understanding. On the 20th of July, 1969, Apollo 11 successfully landed 2 astronauts on the moon. It not only allowed the U.S. to overtake in the space race, but also produced thousands of technological spin-offs that changed everyday life. More importantly, Apollo established America as absolute lead in high-end manufacturing, aerospace, and electronic information, laying a solid foundation for the Space Shuttle program, International Space Station cooperation, and even Mars exploration, pushing the roots of technological dominance beyond the atmosphere itself. These 10 mega-projects, none of them were flashy, vanity projects. Each one precisely struck the core pain point of America at a specific stage of development. Even today, these projects are still shaping America's path. Their engineering ideas and construction experience have become valuable assets in human engineering history, continuing to influence the direction of mega projects worldwide. Thanks for watching. See you next time.